Hello, everybody. So, they
Okay, I have my computer muted, but not.
yeah, what I always do is just deactivate the audio when the Zoom's call. So, day two of SDEV 148, Introduction to Game Development, Design, might be a simulation in the name somewhere too. That's another important one. You're going into this field, what engineers need done when they make a new product is the same thing. Basically, the same thing that game developers do, especially when you go for that realistic physics and stuff. The only difference is you don't try to stop the engineer from testing their product, but it's still, we code them up with basically the same thing, same software.
Yeah, a lot of simulations just use game engines like Unity and that.
Because they're more accurate.
Yeah, because people spend years perfecting games on them to be as accurate as they can be in that. So
So it's
hilarious.
The skill applies to more than just video games. So getting into our first example today, mostly we're going to be following along stuff. And by example, for those that haven't had me in class before, this is how I usually do software development classes, where most of it's going to be screen share, typing code. You'll want to follow along, right? That's how we learn to code. Follow along. Oh, it's all right. One thing I always like to do in the programming classes I took that weren't online classes is I would to change it up just a little from what the instructor was doing. Not much. That way I can still ask questions or something like that. Oh.
Is the control for that TV over there?
Oh, sorry. Yeah, y'all might need to see that. But yeah. Let's see if I can. What TVs are on? Okay, it looks like several people are logging in. I think say something about that in a second. So we're gonna follow along examples. I always like to change it up, help to confirm that I knew what was going on, understood what was going on, but not very much. That way you can still ask questions. This is game development, so we're gonna have sort of a small example. We're just gonna today we'll start our graphics pipeline, set up the clock, put a character in there, move it, maybe do a background in, see how our time goes. So we want to make sure there's plenty of time to actively practice afterwards. So if you want to follow along right with the example, and then after class, change it up a little. Right, we're gonna. I'm probably just gonna draw a person and put him on some background, walking around. Then afterwards, you could like after class make it a blue background and draw a fish instead of a person or something. Change it up a little and adjust the numbers, make sure you understand what's going on, because that's the big thing. Understanding. We don't want to just copy exactly. And it is a follow along example. So those in the classroom, there's the big monitor up here. Even before the pandemic brought Zoom into the classrooms, I was still broadcasting software development course examples across the internet. It's on Google Hangouts back then, but our class examples are just text files. So kind of hard to read that off a projector or something. So if you want to log into the Zoom call, that's a good idea. If you're here in the classroom, you can use the campus computers, and that way looks like everybody has a laptop in front of them. 100 doesn't. If you log in, there's 2 computers at every desk, but only 1 chair at every desk. So everybody has at least an extra computer right in front of them. You want to log on to the Zoom call that way, and then it's like you have lots of screens around, might be a good option. If you don't have user accounts yet, the username and password for these guest user is SOIT guest, all lowercase, for School of IT guest. And all right, that's really big. Then the password is Sellersburg, but it's misspelled. Sellersburg 2022, but there's an extra E in it. First time I lived in this town was when I was 12 years old, and in 1990. And that extra E took me a long, long time to get used to after 30 years of knowing how to spell the town name. So if you know how to spell Sellersburg, watch out for the extra E in the username and password. Then you can log on to the one here or use your own computer, whatever you're most comfortable with. And one other quick note about computers, just a reminder that I just use the instructor station for the TVs in the room and the camera. I prefer to use my own computer. So if you want to send me a direct message, make sure you send it to my laptop, which is says Chris PC today. Make sure you're sending direct messages to the right computer. I don't always see them at the instructor station. Adjust what's on the screen in front of me real quick. So I can see the chat room there. So the plan for today is just, kind of talk about the general structure that we follow, that all game engines follow with basically every game we write. There's a certain order. There's a sequence that everything needs to follow every time. It's consistent across all of our game engines. And then there's an order to do things in that we want to pay close attention to. That actually, as you get more advanced, it makes a big difference about that order. So I guess I'll start with this picture. Now, I guess I can put the paper in front of me. Have that to look at. And then I'll keep referring back to that. While we go through our so anytime we set up a game engine, everybody get this password? Should be easy to remember. School of IT Guest, all lowercase, and then Sellersburg 2022 with an extra E. I need the room to write the picture. I guess I could have wrote that to the side or something, but there's basically 3 parts. So first thing we want to do is initialize the game or the object. This is an overlapping pattern. We do it for the game overall. And a lot of our game engines, that this part the overall one will already be handled for us, and then we'll do it on the smaller scale. Do it for the overall game, and then we'll do a same pattern for each object we put in the game. There's the initialize it. What about my picture? Main loop. And initialize it runs 1 time. Then we'll go into our main loop. Which runs forever. I'll probably remember in early programming classes or most programming classes, they give warnings about infinite loops. Sometimes that is what we want, right? Just an infinite loop, and we'll force it to crash when we're done playing the game. So when you use PyGame, a lot of people just write the while loop as while true. There's no way to exit that loop whenever we set it up that way. So we're going to change that up a little bit more, something a little bit more graceful. So we have a way to exit so we can get to the third part in the sequence. But then basically the main loop that goes over and over and over forever. I'll put quote marks in there. This is also the frame of the game. So we initialize everything, set up all our variables, put things in positions, load in all the files we need. And then we just go into an infinite loop, and each pass to the loop is 1 frame of the game. And then the shutdown. Which is just for a graceful shutdown. I'll go ahead and fill that one out. That word I just said, shut down gracefully. Cleanup RAM. RAM and registers and all those resources that our game uses, the hardware and stuff. We want to finish that up so that other software can use that RAM before we're done. That's typically handled in the background. It doesn't really show up much in programming anymore. In most of the software development classes, we barely even mention that. We'll say things like Python has great memory management or Java has great memory management. That's why we like using that instead of C++. We do still have access to that stuff. Back in the days when everything was written in C++, we had to keep track of that. If we didn't say, okay, we're done, empty out what's in bit number 3204 and RAM chip, it was going to stay there forever and nothing else could use it. But anymore, we just kind of say it's covered, and game engines usually handle that for us. Depending on the language, we might want to notify the language's garbage collection that we're done with our objects at the end. It just says shut down gracefully at the bottom. Sorry. I wanted to stack the picture so I could keep pointing at it, but yeah, just the basic shutdown stuff. Initialize, this is, we'll import some libraries, whatever we need, libraries, packages, modules, kind of the same thing. We just have a different term for it in all of our programming languages. If we were in Java, we'd call it, writing stuff in Java, we'd call it a package. If we're writing stuff in Python, we'd call it a module. But the pre-written code that we import into our text files in order to use. We need to import those. Initialize and place objects as far as location. So go ahead and declare that we have a variable that represents our player object, and then set it to a position, because we don't want to do that in the main loop. We don't want to keep adding a new player object every time we go through that loop, because that's going to burn through RAM. Depending on the situation, it might get cleaned up automatically, but then if it does that, it's going to slow your game down because you have to clean up RAM every pass through the loop. So we want to just create it once and then use the same one all the way through. And recycle as much as possible. I think everybody in here is probably well aware that games are one of the examples we still have, that computers have gotten very powerful, and every year they get more powerful, but we can still grind them to a halt. And it happens with games pretty easily. So recycling things, right? If we have a bunch of prop objects like pickups sitting around a room for the player to find, when they go in the next room, if we're not reloading the scene, we're still going through our main loop, we don't necessarily have to create new prop objects. We can have 5 or 6 that are initialized that we can just use in a different situation. Which, if you haven't come across those words, initialize is just where we say we have a variable. So something in the C family, we have to give it a type. Maybe we have an integer. We're going to call it X, but we don't do anything with it. That's initializing. Then defining it is when we give it a value. Then somewhere else in the code, later in the code, we'll say X is the number 4. End of instruction. So initialize and then define. Probably want to do that up here. I'll put define here, but defining we can also do down here and help with recycling things. And then we're not creating extra spots in RAM. Game development is the place where where we just still have to worry about RAM, because we'll run out of that pretty quickly. In a lot of situations for games are very widespread, right? We could be making a Sudoku game or a crossword puzzle. Those things are fun. People like to play them. So there's still a market for making them, but it's usually when we say games, we're thinking about the big ones, the massive 3D open world, multiplayer, online. Those things we have to worry about RAM quite a bit still. And I'm going to say define the default values. Where are we starting at? Define our defaults. which is like position, score. Those are probably two that we have almost every time. Booleans come in very, very useful, etc. There's a lot of things we'll have, but Booleans make a lot of things easy. In a lot of ways, game development logic is easier than some of your business situations because we have this main loop to work with. It's constantly running and running pretty quick. Usually 60 frames per second, 140 frames per second are kind of the standards these days. Depending on the situation, we can set it to faster, or we have control over it. So we don't have to worry about repetitive things quite as much as we would in business situations where we need to do it all at once. So mostly what we're doing is doing a selection structure each pass through the main loop, which would be the frame of the game. We're deciding what needs to happen on each time. And then this is the order that's that we want to pay close attention to. So first thing we always want to do as we pass through there is listen for events. I'm going to put react to events. Events being, for event-driven programming, that's anything that can happen. Press a keyboard, a timer runs out, the mouse moves, some audio event, the close button is clicked. An event is basically anything that can happen, anything the computer can detect. First thing, we want to check and see what events have happened. And then we'll need to react to any of those events appropriately. If the mouse moved, is that controlling our camera? Does our camera need to pan? Does our character need to turn around? What does it mean for that mouse movement that we just heard? We want to check physics. You might remember why I said the other day, I said physics is the absolute critical part of physics. There's a lot of things that we'll use in physics.
Boundaries.
Yes. Boundary between things, how we can tell when things bump into each other, when they should stop moving, when they should bounce around. And physics engines have grown large. So as a bonus for that need, we get basically the laws of physics from our universe are already programmed into the engine in any situation that we're going to use. If we're coding it from scratch, obviously not. If we're coding it from scratch, we have to have that boundary around things. Process physics. I was trying to avoid that word, but I could. So notice how it's doing two different things. We're checking our physical states, but the calculation is something entirely separate. So I wrote them next to each other, but they don't necessarily have to be done right next to each other. Should probably do that one first and that one second, but we could check physics way up here and then process at the end. Then we're in our room. I'm going to call it normal movements. So this is the one the game's doing automatically. The AI controlling the mobs and the NPCs. The trees animated in the background. All the stuff that's happening regardless of what button was pressed, what physical interactions have happened, or not happened, what physical interactions have been simulated. Regardless of that, we're going to have some things continually moving in the game. And then update our graphics. Because all of this is just calculations, right? Was the A key pressed? That's a common one. That's just a Boolean because it was either pressed or it wasn't pressed. Mouse movement would probably be a floating point number because there's a whole lot of range for the mouse movement. It's not just true or false. Yes, it moved, or no, it didn't move. But all of this is processing and the graphics are separate. So looking at that order, somebody want to tell me why events are a good first thing to listen to? Why we want to do that first?
Because that's assumedly what the player's doing.
Yes. Player priority. Same reason our keyboard and mouse always get human priority, because well, on first pass through the loop, nothing's happening. But after we get down here, the player's reacting to this, right? Player's not looking at all the numbers from those physics calculations and reacting to them. They're reacting to the update graphics. So if we did that in the wrong order, like we did that last, the player would be reacting to an old situation. And before long, the game might seem like it's lagging or something like that. It's always a little bit off. So this is the general order we want to follow. We're not stuck to this order. And actually, we'll see it when we get to the Godot engine, which I stumbled across something last night or 2 nights ago, maybe the other night after class. Apparently, one of the original developers said it should be pronounced God-O. So the T gets pronounced like an O, and then the second T, yeah. Or no, the second T doesn't get pronounced. But however you want to pronounce that, there's lots of ways to say it, but that is pretty common in more game engines than it's not. We have control over whether the physics or graphics gets priority. So the way I wrote this here, right? We listen for events, then we do the physics, then we do the graphics. What do y'all think? It's 50-50 on the guess. Is this physics or graphics priority? Not quite. Close. That is a good guess, though. It makes sense because of the order. That's why I called it a guess. This is what the user sees. So if we switch the order, if we did the normal movements, then our graphics, then our physics, to make more sense seeing them side by side. This way, the event, when the user hits the button, is closer to the physics than the graphics update. So if things are like moving really, really quick, going all over the place,
the player won't see it because the graphics won't change before the physics already has moved everything and reacted.
Does that make sense?
Things will be phantom, basically, where they shouldn't be, they are.
Yes.
From the player's perspective.
So yeah, so in the Godot engine, we have two options on main loops, and one of them is graphics priority, and the other one's physics priority. Which actually, yeah, that's why I asked that question. It happens in the opposite way of what we would expect. So think about the last thing the player sees. So if the graphics have updated and the player knows, right? Y'all play games. Your intuition is going to notice that quickly, right? It's happening 60 times a second, super quick, but you're going to notice that you're going to notice that the actions supersede where the graphics are. Just by a split second. But there's so many of those split seconds that they start to add up and our mind takes notice of it. Just something to note about the order, because obviously the order here doesn't matter. It's just sort of a recommended one. Some sort of recommendation. The big thing is you always want to do events first, because no matter which one of these you give priority to, like as far as the last thing that happens, very last thing that happens in the frame before we go to the next frame, first, that's what the user is reacting to. And by priority, we're talking a couple nanoseconds, right? Everybody, right? It's 2 lines later in some code.
It might not seem like much, but to a player, it can be very glaringly obvious. If something's not lining up right.
Yes. That's why most of our engines give us the option of which one it is going to be. If it's something super fast paced, like a super fast paced FPS one, you're probably going to start predicting where things are going to be, not necessarily looking at where they're at. In that case, you'd probably want physics priority. If it's a brightly colored overhead world thing where you're there's been quite a few, like Stardew Valley. It's nice and slow. You're doing things, not in a hurry. You probably want the graphics to have priority because that's what the users are reacting to every time. So the situations change. That's a big thing. And as you all read through the textbook, that's what a lot of the textbook is about, the concepts and the frame of mind we want to be in for a particular type of game. Oh, by the way, was the book down there?
Yes, I got it.
Okay, I see it. Okay, yeah, it's a lot of conceptual stuff there, and then the questions at the end of the chapter will have you thinking and doing stuff. So those are the writing assignments. I also have some doing assignments, which what's written there is following along the tutorial. But if you would prefer to take our in-class examples and extend them into your own game, I would be willing to accept that. Like, okay, that tutorial just doesn't strike me as interesting. Like in PyGame, I think I put 4 tutorials on there. It's like, choose one of these. It's like, okay, those don't look interesting. I want to do my own thing. I want to remake level 1 of Mario because that's a classic, and it seems like that's, if I figure that out from scratch, that's going to be better practice to get into game development. And I'm like, yes, that is correct. So that would be acceptable, but obviously it's a little bit harder and to figure some of the points out. Actually, Mario is not that bad. It was a little bit harder if we did it all from scratch the way they did in assembly language, and half assembly language and half pure electronics itself. But if you want to do something like that, I would agree that's better practice. So if you don't like the tutorials, the follow along tutorials, let's do it like a mini project. Let me know what you want to make for that one, and I will probably be okay with it. If anything, it's most likely that I'll tell you something that's too big and to drop some features. I haven't seen it happen where somebody asks to do something too small, because we're just getting basic syntax practice, just basic syntax with the. So just if you want to take our in-class examples and just go a little bit further with them, right? My general plan is probably an overhead thing. If you want to switch that to a platformer, and then look at the character from the side instead of the top, or top side angle, and have gravity pulling them down. You want to code that up. That will be better practice overall. So you don't have to perfectly follow the instructions in the tutorial. And if you do follow the tutorials though, I would ask that you do a little bit more. Customize something. Change something up in the tutorial. So perfectly following the tutorial will get you a B. Does that make sense? You can bump up to an A. You have to do something on your own. One of the best things would be replace some of the artwork with your own. All the tutorials I put in the assignments have links to where you can download the artwork they used. But with games, we can't really separate programming and art. They go together. In big industry level, if you're working on a huge team, there's going to be specialty. But because of the nature of the field, they're still interconnected. You need to know about the others. So you will not be graded on the quality of your art. The quality of your art will have no impact on it, but please do your own art. On your final project, you do have to use your own art. That's the requirement there. It has to be your own art. It does not have to be good. There's no quality restrictions on the art, but if all you can do is a stick man in Microsoft Paint, then move the stick man around. Right? Start getting practice, because that does take practice. Yeah, let's start getting that practice. So first thing we're going to need is we'll do a little bit of art. I'll show you the 2D software I like today. Involves vector graphics. We talked about vectors the other day. This is sort of some important reasons we want to use vector graphics.
That's the Inkscape thing. That the Inkscape thing.
Yes. So Inkscape, that link I sent out this morning, that's an open source alternative to Adobe Illustrator. So if you like to buy really expensive subscription licenses. Adobe Illustrator would be the difference. Inkscape has been the premier alternative, open source alternative for a while. The biggest difference between that and Illustrator is Inkscape doesn't have CMYK colors. That's cyan, magenta, and yellow. You remember back in elementary school where they teach you red, yellow, and blue mixed for reflected light colors? It's actually cyan, magenta, and yellow. And in kindergarten, when we first learned that, most of people don't know some of those words, or you might have trouble saying magenta or something. So they say red and blue. But CMY and K is either black or clear, depending on type of printer. Right? Some printers still have lasers that actually burn stuff, in which case you want clear ink. That's why it's K, not B. And other printers still use black ink. So whatever the K is, turns black on the paper. But for games, we're not going to be printing anything. So we don't need the CMYK colors. We want the RGB colors because we're going to put them on the screen. It's just a different way to mix and get the same values. We can get either any color either way. But on the screen, we need RGB. So we'll be using, we'll start with PyGame. This is a nice introduction. Has everybody seen the Python programming language before? See head nods in the class. Python is created in 1989. Really interesting story about it. I always like to point out this story. He couldn't get out of a family event, so he made up an excuse to get out of talking to people and sat in a corner. Most computer people can relate to that story. He sat in a corner and it's like, oh, I got this big work project. I'm really, really busy. By the end of the week, he realized he was onto something really, really good. And when he got back to work, he shared it with his coworkers, and he really took off from there. Everything about it is basically to make it easier for the human, the programmer. Trade-off for that is we put the work onto the machine, which makes it slower. So it is one of the slower languages, but by around 2010 or so, that wasn't so much of a deal anymore, and it started getting popular. And then there was a big breakthrough in machine learning, which involved processing data sets, where if we used our fastest language, we would still like start the program, go get lunch, come back from lunch, and still wait an hour to finish. So might as well use the easiest language in that point in the case. And that really bumped it up to the most popular programming language in the world, because with the obvious exception of the one that's an international standard. JavaScript's an international standard, so there's no competing with that for the most popular. But as far as what people choose to use, Python's the easiest one to work with, and we make the choice. So a lot of people choose Python, but it's great for starting it out. I know here in the classroom, everybody was nodding their heads when I asked about that. So hopefully the Zoom call was very, very similar. I think everybody's seen that before. Big thing about Python is its white space matters. Significant white space. So instead of curly braces and semicolons, semicolon means end of instruction. I have it written on the board over here. Oh, it's not on the camera, can't see it. And an example I wrote on the board that nobody pointed out wasn't actually in the frame of the camera. A very quick example had semicolons in it, and semicolon means, technically it means next instruction, which computers read our text files backwards. But from where it goes in the text file, we want to think end of instruction. In Python, to make that easier, we do line breaks. So you enter and go to the next line, and each instruction gets one line. And then to block the curly braces were traditionally used for blocking things together. Take multiple instructions that go together, we go inside curly braces, and we call it a block. And with Python, we just indent all the instructions that go together. Kind of nice. There are drawbacks. Looking for a missing semicolon is nothing next to looking for the missing white space or the extra white space. If y'all have seen Python before, you've probably seen indentation error. This get very, very frustrating, because that means that there's no symbol for the part that's for whatever the error is. We have to just kind of find it without being able to see it. Pros and cons to everything. The big thing is it's slow, so PyGame isn't super popular. There's lots of ways to use it. Did everybody get Python installed?
I didn't know install
You didn't install PyGame or Python? So, let's look at the installation.
I think I did. I think I got mine installed.
Okay, so to download the language, you can just search for download Python. Should go right to the page for it. The latest release, so version release patch, the releases come out in October. So just a couple weeks ago, 3.12 came out. It's fairly new. Just download that, run the installer. This website should recognize what type of machine you're on, and you'll download the one for the correct installer. Once that's going, we'll need to install things. So you want to go to whatever terminal you use, whether PowerShell or Bash or Zeesh or command prompt. Command prompt doesn't actually do anything anymore. If y'all didn't know that, they removed it and people complained. PowerShell was an updated command prompt, so it uses modern syntax. It still accepts all the old instructions. But PowerShell, once PowerShell they felt it was thoroughly debugged, they removed the traditional command prompt and got a lot of backlash. So then they put in something new that just where you type the traditional instructions and it forwards it to PowerShell to run them in the background, and that made people happy. It doesn't actually do anything, and you can just put the old command prompt instructions right in PowerShell. Bash or Zeesh or whatever terminal you want to use. And to install things that aren't in the default language, there's a lot of ways, but what comes with the default installation is the preferred installer package. So pip, we type pip install, and I can zoom in, can I? Okay, oh, it's a little bigger on the screen. So pip install, and then whatever version with whatever module we want to install. And you can do equal and then like some number 1.8. I think no 1.2.8. I think that's what we're up to. You can do an equal to, but if you leave off the equal, it'll just do the latest version. You just need to do that if they like remove a feature in an update and you want to use the one from before that feature was removed. So just hit install PyGame. You run that instruction. It's already satisfied on mine, but if you don't have it, it should run a couple. You'll see the meters as it downloads things. And then to check that, we can go into the Python interpreter. And if we just type import PyGame, that first line, like we would put in a script when we're ready, when we're gonna start working with PyGame, what we'll see in a moment. Whenever we import the module, it automatically gives us a little greeting. So if you, in your terminal, type Python, is anybody on a Mac or a Linux? All right, if you're on a Mac or a Linux, type Python 3. Part of the operating system kernel was written with Python 2.7. So it always goes with the lowest version of Python. If you have multiple versions, right, if you had Python, maybe Python 10 from a previous class, and you want to go ahead and down and then install Python 3.12, you can keep adding digits 3.12 until you get up to the one that you want. All that's been released so far is 0, but maybe in a couple weeks, go ahead and install, or in a couple months, 3.12.3. You start doing something, it's like, oh wait, I need to go back to 0. You can type the numbers in with that as well. So you can have more than one version of the programming language.
So I did the pip install PyGame. It said pip is not recognized.
Okay, so you'll need to set the environment variables. You're on a Windows machine, right?
Yeah.
Okay, so on a Windows machine, There's a couple ways that you can go to start menu and search for environment variables. Environment variables are the operating system variables. So basically what our terminal knows about. And under the advanced tab, when this opens up, oh, I clicked that really quick, didn't I? It's actually edit the system environment variables. I started typing environment and it showed up pretty quickly. When you select that, should see the system properties. And this is a general programming thing. So this is how your computer knows about a programming language. Anytime you go to put a new programming language on it, you have to set an environment variable. There's a checkbox in the installer that used to be checked by default, but then they stopped checking it by default because Microsoft wanted them to stop checking it by default. But, a long story to get into it. But
Microsoft doesn't want anything they don't want.
Yeah, it made sense. I guess what part of the argument was security. Then computers aren't all set up to automatically run Python. Person has to actually say this computer can run Python code. So because it's an interpreted language, which means we never compile a file, we run it one instruction at a time. We'll grab one instruction from the text file, translate that to machine language, run that, and then come back and get line 2 and repeat in just one line at a time. So it can run from text files like email attachments and things. And that's an extra security risk that we don't have with, say, C++, where we'd have to actually compile the code, take all of the instructions and turn it into a huge machine language version of instructions before it can run. Okay, so once you get to environment variables, you'll see this one path under the system or the user. For Python, you probably want it on the user one. If you don't see it, just click new and create a variable called path. Path is where all of the programming languages the computer knows about are. And then you'll just need to point to where it's installed. So did you just use the default installation of Python?
I just click install.
Okay, so if you went with the default, you'll go in the C drive and the users folder in your user account. So all of us have a different account. There's a folder called app data, but it's hidden. So you might need to come up to the little ellipsis and under options.
Yeah, when I click browse folder under the edit environment variable thing, it does not have, it's a different interface.
Actually, you'll need to go to File Explorer first. So you have to come here. If you open File Explorer,
Okay.
and on the 3 dots, the little ellipsis, the more stuff, go to options.
There is no.
We need to see hidden folders. So under view, there should be a checkbox for show hidden folders.
Yeah, there we go.
Yeah, because Python was installed in a hidden folder. So we have to turn those on. Once you can see the hidden folders, click a new one and then browse. And it's under the user account and app data, local programs, and then Python folder right there. So you want this folder called Python, but you also want to come up, you'll notice there's also a folder called pip. You want to make one that points at so you'll add 2 to the environment variables, one that points at the pip folder and one that points at the Python folder. Everybody see that? Everybody able to find that? Yes. So would it be easier, Max, if I did it in the other browser? I think it's easier to see over in this one. So what we do is go into the users folder.
You also have to click new first. New,
Oh, yes. You click new and then browse. What I usually do is go in this way and then copy the address. So in the user account, there's a hidden folder called app data. Control dot use control period used to toggle hidden folders on and off, but it doesn't anymore. So now we have to go through a menu to turn hidden folders. But in that app data folder, yeah, this is why I like it, so we can see it up here at the top. That other interface doesn't really let us see it. In local, and then right there's the pip folder. So you want to, doesn't hurt to have that on there. The one you actually have to have is in programs, in Python, and then with Python 3.12.
not just Python new.
Yeah, Python 3.12. So you want to go to where you can see this file, right? See this file here, python.exe. That's the Python interpreter. So basically, we have to tell our command prompt or terminal, bash, zeesh, whatever we use to control the operating system. We just have to tell it where the Python interpreter is, how to run where the software that knows that runs Python goes.
Does it have to be that way? Like, has it blanket installed up there? Can you just do the default installer? That's what it is.
If you go through the installer, on the first screen of the installer, there's a checkbox that says add to environment variable.
So,
Yeah, you have to check that text box. It used to be checked by default, and it was only in the last year that they stopped checking it by default. And yeah, then if you just click browse, it's over here. What I usually do is I go in this way and then just copy and paste that address over.
I mean, like the installer from like the actual website.
That's probably if you click that checkbox, it'll automatically do it. So you see which three it put on here. So it pointed to those three folders from the installer. So Python 3.12 scripts, Python 3.12, and Python launcher. That's what if you check the box in the installer, it'll add those three. So if you're doing it manually, you might want to add those three. And then you'll have to restart your terminal. So that's consistent across any command line interface. It only checks the environment variables when you first start it up. Is anybody on a Mac or Linux? I think this is the message I saw a moment ago. Okay. Nothing coming in the chat room, so I guess there's no Mac users. In a Mac and a Linux, we have to do environment variables from the terminal, which is really, really easy. It's just the path variable equals, I'll type it in here just in case. We want to export the path variable and assign it whatever that address is. I'll just put address /2/Python. This is a Mac instruction. Nobody responded when I asked if you're on a Mac. We do that, then we put a semicolon, and then put $path, or just path. We put path. So this new address concatenated with what was already in the path variable. Path equals new address plus path.
So that path thing you're referring to, isn't that like on the installer, you click that one, is that what you're saying?
Mm.
Okay,
Yes.
that's what it is.
Yes, it's much easier if you click that checkbox, but a lot of people don't know to click that checkbox.
Oh,
But now Python should work, right?
Yeah, I don't see a launcher part.
Oh, so I just went to PowerShell. If you have,
No, I was talking about under there's the program // you can see that one.
Okay, I might have installed something extra. Maybe that was just, maybe that's what you get if you get the checkbox. But as long as you go to the Python one, it should be good. Now, if you restart your terminal or command prompt or whatever you're using, I'll just use PowerShell. If you type Python, does it go to the Python interpreter for everybody?
I mean,
Yeah.
I typed Python and it opened the App Store.
Oh.
Okay, then I already downloaded Python, but it just
No, let's not use the one from the App Store. The one from the App Store, we'll change your registry and it will do strange things. Can I see what it's doing?
yeah, I already did download from Python.
So did you run that installer and everything?
Yeah, and then when I do
we type Python install, right? Sorry, I just,
Oh, yeah, just search for download Python. Yeah, close out of
sorry,
that.
I'm very
We don't want to
slow.
do Microsoft Store. Restart your terminal. Maybe it just hadn't checked the environment variables. Still doing the store.
Quick question, this is the one we hit, right?
Yes. Yes.
Sorry.
Oh, it's all right. It's all right. So go ahead and download that. And when you run the installer, on the very first screen, there'll be a little checkbox at the bottom of the screen. Check the box that says add to. So. Well, that's good. I'll put a slash at the end of those. I don't know why, but we want to go in the folders. We don't want the folder itself.
Do I use admin privileges?
okay. And then that should be it.
You'll need to restart PowerShell.
Okay.
If this doesn't work, maybe just go with the Microsoft. It'll do another install. You can have multiple ones. Then we can try that.
In the video we discussed.
I'm not sure why your computer's set up to do that way, but if you just go ahead and get it from there. It should work.
I don't want to do anything involved with that, honestly. What the hell? Why? It's more Windows stupidity.
Yeah, I think
Maybe I should download.
yeah, re-download it and run the installer, and let's see if it will just have a correction thing in it.
It's just PowerShell.
Oh yeah, that'll work. Yeah, the first part we were gonna do for our example is gonna take about 10 minutes, so we've still got time before the break. Modify. Yes. Next. So it wants to add all those things. Then just check this. So now if you hit install. Now it should,
Hopefully.
hopefully. For command prompt, it's been PowerShell. Maybe one of the old ones will work.
Yeah. I just don't trust most of what Windows does, especially after I realized I couldn't, no matter what, get rid of damn Microsoft Edge.
Yes.
I even looked up. I even looked up a command prompt to force it uninstall it. It just ignores it.
If you use the one from the App Store, it changes the registry in such a way.
No, that was the Edge that was on the computer.
Oh,
Because Edge is part of Microsoft.
yeah, you can get rid of them. The space at the beginning, do it without the space at the beginning.
You can't browse.
That might have been missing up.
I'm sorry.
Let's look at that at the break.
Is it?
This computer has it on. You want to try to log in with it to this one?
Do I go to the?
We will need to import the module. You can try the one from the Microsoft Store. They get a little funny sometimes. It changes your registry in such a way that a human does not have access to change it back if you use one from the Microsoft Store.
Down.
Oh, users. Users, I did that. Oh, right.
So I want to go ahead and get started in the example. We'll look at that in a few minutes. Ready? And if you just want to kind of keep track of what's going on, you can type the code and stuff, and then we'll look at it. We'll have plenty of time at the end. The first little part here is going to take us about 10 minutes. So if you're able to do that and install that, we need a place to write Python code, some sort of text editor. We need some place to write text. I'm going to use the one that came with Python. So when you install Python, you should have got this IDE called idle. I'll just use that one because everybody has that one. There's much nicer ones we can use. Different text editors. And I'll create a new file. Has everybody seen idle before? Yeah. A text editor, and then a place to run our code. Nothing too fancy. When you open it, search for idle. It'll just be the place to run it. Under file, there's a new button, and that'll get you your text editor. So, well, like what we did for the check, first thing we want to do is import the PyGame module. Then back to this picture. So this is the pattern we follow. We want to initialize things, do our main loop, and then shut down gracefully. So I'm going to go ahead and initialize PyGame. So the PyGame module has a method built in called init. So we'll initialize that.
Just to try, what was it was pip what now?
Pip install PyGame.
Let's see what how it reacts.
Yeah, because if you have another place to run that,
Well, in my previous class last day weeks that she showed us Anaconda.
oh, okay, you can just do conda install PyGame. It's been very popular for like 25 years. Since the late 1990s was when PyGame 1 came out. So any of our installers, if you have Anaconda on there, just use that. I just use PyGame to avoid installing Anaconda and getting into all that. Yeah, you say you saw it in the last class. It takes a while. There's a lot to it. Okay, so that initializes our module. I'm going to go ahead and set up a clock because that's one of the things we want to worry about. So to deal with that, I'm going to just create a variable called clock. So the timing of our game, frames per second. I guess that would be a better name for it, but I already typed clock. So we're going to use the PyGame module, and sorry, I completely forgot. I should probably Zoom work in here. Nope. Let me change my font size so you can read that. In 16? I think we can go bigger than that. Okay, there we go. Is that easy to see? All right. So the PyGame module has a submodule called time, and in that is a variable called an object called clock with a capital C. So we want to create a new clock object. That's why I call it clock, but FPS might be a good one because that's how we're going to get our frames per second. So we've got passage of time now. It's an important part for initialization. Now we need our graphics pipeline. Okay. Those multiple parts we talked about the other day, graphics pipeline is one of our main ones. So to do that, I'm going to make a variable called viewport. That seems like a useful reference. Everybody said they've seen Python before, so y'all know how to tell what parts we can rename and what parts are from the library, right? I see head nods here in the class, so hopefully there's similar head nods on the Zoom call. So the viewport, again, we'll look at the PyGame module. Oh wait, sorry. This one I just meant to do is the size. How big is our viewport? How much are we looking at? Maybe we can call it that. Just make it clear. Windows size. And everything gets handled as a vector. So very rarely do we have single value. So we either need to make it a list or a tuple. I don't have it. I almost always use tuples. Everybody's seen the difference between lists can be changed. Tuples are immutable. So that means if we want to change the numbers, right? Let me put a couple numbers: 777, 444. That sounds like a good size. 777 by 444. When you're looking at the game development, you'll see a particular size that was used for years and years and years. It's drilled in everybody's head. 960 by 480. Anybody heard those numbers before? That was the ratio of a cathode ray screen. So that got drilled in game developers' heads for years and years and years because it gave it the correct ratio for cathode ray tube, but our screens are not all the same size anymore, right? So whatever size you think is good for us to look at. And for a list, we use square brackets. That means we can change the values, or we can use parentheses if you haven't seen tuples before. And it's just like a list. We'll index the values individually if we need them, but it can't be changed. If we need different numbers, we have to make a new one. We can't change these. Tuple. So list with square brackets, tuple with parentheses, and immutable is the word for that.
The tuples, two of them, it's not like two here and two right there.
That would be a nested one.
Oh, okay.
So we could do nested tuples, nested lists. There's lots of different ones. We also have sets, but then we don't. It doesn't preserve order. I always use tuples here, but notice it is a vector. That's why we talk about vectors the very first day. One thing we do is a vector. Our x and y's go together. We don't do like in math class, the x-axis and y-axis. We don't do something solely on the x. We're always working on both x and y for 2D. For 3D, we're always working on x, y, and z. So that once we have the window size, I'm going to create something called scene. That's just the name I've developed over years, and a lot of game engines do call it scene. Do go with that same name. The scene is the thing we're actually looking at, the result of the graphics pipeline. So window size is, well, like the name says, it's just size. And that's going to be PyGame. Don't do anything fancy here. Nope. PyGame.display set_mode. And then we'll pass in that window size. Let me get the Zoom thumbnails out of the way on the screen. So I just did the window size on the previous line to make it obvious what we were passing in there instead of having multiple sets of parentheses there. So that's our graphics pipeline. Right? Our initialization, we have a way to set our timing. We imported all the modules we'll need. Way to set our timing, the graphics pipeline, Now we'll need an infinite loop. So we could say while true. A lot of people like to do this, but I want to modify that just a little bit so that we do have control over it. So I'm just going to make a little variable. I'll call it plain and set that equal to true. And then use that variable here, while plain. So it's still an infinite loop. It's just saying while true. So it's going to run forever. By syntax in Python, while, and we look at a condition, and as long as that condition is true, it's going to keep running. But this gives us a way to shut down gracefully, which is just a good habit. PyGame's built in because it's been used for so many decades to introduce people to game development that they went ahead and built in it automatically does the graceful stuff in the background, but I wanted to include it here because we do need to think about it in other places. Well, we already talked about what's the first thing we need to do. Stand in front of the board, so maybe y'all can't. Remember what the first thing we need to do is?
Look for inputs.
Yes. The inputs or events. Generically, we would just say it's something that can happen. So inputs get priority, but also timers, right? Because if we ran out of time for the level, then we don't care which buttons the user hit. They're in out of time. If they like in the original Mario, if they fell down the hole, we don't care if they hit the jump button again. So those are events, things that can happen. We want to check for those. So we just want to loop through every possible event we know about. So for event in PyGame dot events. I have to check the example. That's why I pulled one up in front of me. Event, yes. PyGame.event.get. And everybody's seen for loops in Python, right? So this gives us a big long list of events. It's actually a generator of events because they're quick. So it's more RAM efficient for those who have had, I guess that shows up in the 220 class. For everybody else, let's just say we have a big list of events, everything that the computer knows about, and we're going to go through them one at a time and call each one event as we look at it. Right now, there's only one, at least for starting lists, there's one we care about, right? If that event type happens to be PyGame.quit in capital letters, and everybody knows, figure out what quit is, right? It's a big X up in the corner. So if the user clicked the big X up in the corner, let's set that plain variable equal to false. So now we do have a way out of our infinite. That's just good form. Pygame has been used by so many beginners that we would probably want to do that. We wouldn't have to worry about it. It automatically happens in the background. But in other situations where y'all probably wanting to move to bigger, more powerful game engines soon, right? This is just our introduction because it matches the picture on the board very nicely, right? Reactive event. There's our reaction. If that X is hit, then we change our variable so we jump out of the loop and shut down gracefully. We'll get to that in a second. Check physics, we don't really have any of those. Normal movements, update graphics. That requires our clock, right? Our frames per second. Oh, went a minute too long. So we set up our timer. So clock, it has a method called tick, and then we'll pass in a number. I always like to do that the very last thing in our frame. I'm going to add some white space so I'm not typing at the bottom. So notice it's still indented there, and then I'll come down and come back out. Let me put a comment here in main loop. That way we can tell where that ends. And then when this goes false and we jump out of our loop,
Should be only one.
more than one's okay. I almost never type one comment symbol because if you only type one comment symbol, it's really easy to accidentally delete it. So I almost always put extra. Sometimes I tend to not put comments much at all. I just randomly felt like doing that. Some of the others who have had me in class can confirm that. We wrote 3,000 lines of code and not have a single comment in it. So also by that effect, I won't take points off like some other instructors do if you don't put comments in. Because I've wrote thousands and thousands of programs that are thousands and thousands and thousands of lines that don't have a single comment in them. So I don't really have any right to take points off somebody for not putting a comment in the program. Oh yeah. Then we jump over a loop, so we undo that indenting, and there's a quit method. So notice the difference. There's the quit constant. That's a value we're checking against. That's something it already knows about, which is just capital letters, no extra symbols except the colon for the if statement. And then there's the quit method, which shuts down gracefully. There's the minimum to run it. Oh, my font size is just a little too big to fit in. Actually, if I do this. There we go. That side. Import PyGame. We know import PyGame's at the top, so I'll scroll down. Not with the mouse, apparently. There's the bare minimum. We initialize everything. Our libraries, we create our clock, create our viewport, our window, camera, set all that up. Then we go into an infinite loop, check for events. The one we care about at this time is just to quit. Set up our frames per second. Nothing's happening yet, so we'll see that after the break. And if we bounce out of that infinite loop, we'll shut down gracefully. Should be good. So let's give this a save. And video games are going to involve lots and lots and lots of files. So make sure anytime you start a project, you create a new folder to hold the entire project. And probably lots and lots of folders in that, because there's going to be lots of images, lots of scripts, lots of different things that come together. And organization goes a long way. What is this? This is I can't think of a name very quick, so I'm just gonna call it class example. And I'll just call this main.py. That sounds like a good name for it. Those who have been up to like 200 level Python class know that main's a very, very bad name. And why main's a very bad name, but it'll be okay. If we don't look at the back end, it will seem like a good name. It'll run fine.
You should name it PyGame.
I'm pretty good with it. That would probably work too. We should avoid duplicating names. And there's some stuff in the background called main. But it will notice that and not call it main. But it makes sense for it. So once that's saved, we give it a run. Do a little message in the background, and there's our window. 777 pixels by whatever number I typed in there. Kind of arbitrarily pick some numbers. So there's our graphics pipeline. We're listening for events. Frames per second kind of seems like physics, right? Goes with both of them. Our animations are moving. That's how we detect checking the physics and stuff. So really that kind of covers that one thing we did covers there. So there's all those basic parts for the first example. And that was over and all. Maybe we finished with that actually about 7 or 8 minutes ago is what I was planning. Break sound good. Anybody have questions before we take a break? And then we'll start doing we'll put something in that window and make it move. At least for that'll make a good start. And we'll spend a couple weeks on that. Following along the examples will get faster. I kind of go slow to start with for those who haven't had me in class, so that you get used to it. You know, your classmates, Grace and Sam can confirm I tend to bounce around all over the place. And I really like coding. And I have fun making games, so the ADD is even more than normal. So there'll be a lot of bouncing around. Please don't hesitate to bring me back on track if I start to get distracted or go down a really deep rabbit hole. We don't need to go down in an introductory class, but That was probably enough time for anybody in the Zoom call to put in something in the chat. So 10 minutes sound good for a quick break. I know I'm ready for a sip of coffee. So my laptop says 2:17. We will get back to it at 2:27. See y'all in just a moment.